Okay, welcome back to 1316 Trigonometry. Dealing with Chapter 1, Section 5, which is some more on identities. Again, I'm David Dipple, Lone Star College, Montgomery, and that's my email address if you want to reach me. In Section 5, it's mainly dealing with utilizing Pythagorean identities and other identities that we learned back in Section 4. Suppose we want to try to write tangent using only sine. Now, if you think back to everything we've dealt with, tangent, its definition, or the identity that we started with, tangent is defined or has the identity sine over cosine. Now, if we only want sines, that means we have to get rid of this cosine on the bottom. Now, if you think through all the identities we've dealt with, the three Pythagoreans, there was only one that had sine and cosine in it, and that was sine squared plus cosine squared equals 1. Or cosine squared plus sine squared is equal to 1. Now, if we want to get rid of cosine, we have to isolate it. So move your sine squared across. So cosine squared is 1 minus sine squared, and take the square root, and you get plus or minus the square root of 1 minus sine squared. So your cosine can turn into plus or minus the square root of 1 minus sine squared. The plus or minus depends on which quadrant you're in. So if you substitute that back for cosine, then your tangent is equal to sine divided by this function here, plus or minus the square root of 1 minus sine squared. And now we've written tangent using only sine theta, not cosine. Because all that's left in there is sines. Okay, suppose we want to add two trig functions. Thinking back to all the identities that we have and all the algebraic manipulations that we had to deal with, in order to add fractions, you must have a common denominator. Now, the first fraction has a sine in it. The common one has a sine and a cosine, so you have to put a cosine with the first one and a sine with the second one. So the first one gets a cosine divided by cosine, and the second one is missing the sine, so you have to put in a sine over sine. You can multiply by 1. So this 1 is in terms of sines, and that 1 is in terms of cosines. Now, if you combine the tops, you get 1 times cosine and 1 times sine. The bottom is sine times cosine. So this is cosine plus sine divided by sine cosine. So we have added these two fractions and gotten a combination with a common denominator. Okay, suppose you want to multiply trig functions. In this case, two binomials. You'll have to multiply just like you did algebraically. You take the first term times the first term. 1 times 3 makes 3. 1 times a minus sine. Sine times 3, and sine times minus sine. That's 3 minus sine plus 3 sine minus sine squared. Now you can combine these signs. 3 minus 1 makes 2. So you get 3 plus 2 sine minus sine squared. So you've multiplied two binomials, and you've created a trinomial, 3 terms, with a constant, 1 times 3, combining the middle two to make 2 sines, and then the final terms make a sine squared. So we've added, we've multiplied, you can also subtract, and you can simplify things like radicals using substitutions. And when you're in WebAssign, they'll tell you what to substitute. For instance, in this case, we're going to use x as tangent. So what's the square root of x squared plus 1? So if x is tangent, we just take our tangent and put it in for x. So you get the square root tangent squared plus 1. Now, if you think back to the identities, this is where they come into this particular part. It's using Pythagorean identities. Tan squared plus 1 was something, and that something was secant squared. So tan squared plus 1 under the radical turns into secant squared under a radical, because tan squared plus 1 is secant squared. And whenever you have a square root of a perfect square, your perfect square and your square root cancel out, and you get, in this case, secant theta. So the square root of x squared plus 1, if tangent is x, simplifies to secant. Now, you can look at that in terms of a triangle if you want to. If you have an x and a square root of x squared plus 1, the square root of x squared plus 1 is going to be the hypotenuse of your triangle, and x is going to be one of your sides. So if you draw a triangle, x, since x is tangent x over 1, so tangent is x over 1, opposite over adjacent, and the hypotenuse is Pythagorean theorem, x squared plus 1 squared, square rooted. And then the square root of x squared plus 1, if you think of this triangle, if you take the hypotenuse and divide by the adjacent side, that's the reciprocal of cosine, which is secant. So looking at triangles, relating your radical to a triangle, you get the same answer. Secant is hypotenuse divided by adjacent. Okay, then we get into identities and how to prove things. In this particular case, we're trying to show something. Cosine times cosecant times tangent can all be simplified down to the number 1. Now, when we're working on these, we can only work on one side. So we're going to work on the left side. So I'm going to take my cosine. It doesn't change. Take my cosecant. It will change. And take tangent because it will change. So change each of those using the definition and or the identity, however you want to look at it. Cosine will stay. Cosecant will change to 1 over sine. And tangent turns to sine over cosine. So you have cosine, 1 over sine, and sine over cosine. Now, anytime you have cosine divided by cosine, they will divide out. And you have a sine on the bottom and a sine on the top. They're multiplied together, so they will cancel out. Your sines will cancel out. Your cosines will cancel out, and all you're left with is 1. This is 1, that's 1. The things that cancel turn into 1s times 1, and so you get 1 is equal to 1. So when you're working identities, if you're in the homework assignment on WebAssign, as you're working through them, pick one side to work on, and then simplify it down, and then when you get all the way through, you should get what you have in this case on the other side, on the right side. So that takes care of all the kinds of examples we'll be dealing with. In this particular case, when you have multiple trig functions combined, that will simplify down to something. Or if you're substituting, or if you're adding, or if you're multiplying, those are all practice with the different trig functions and the trig identities.